Okay, so let's make our weapons actually suit. So I'm going to use these particles from Unity itself. So, go download them, they are free. And particularly, I'm looking at the muzzle flash effect for now. Okay, nothing else. Then we can just go onto our scene, the sample scene, and let's drop it. Let's drop our muzzle first inside the level, and I'm going to drop it underneath my controller actually. Reset it. Yeah, that's not going to reset. Move it forward, and I'm just going to make them go from in front of the character. Okay, retro style. I'm going to have him loop, and it's playing, but I'm going to also rotate it around, and I'm going to scale it up. That looks okay for a weapon. Maybe looping is not needed. Yeah, I think it's not needed. Okay, so I'm just going to leave it as this. There is no play on awake from what I can see. It's not ticked, so that's all work fine. Let's fix our own player first, and then we'll fix the rest. So this is only a single particle, which is going to work into our favor. And let's open up our controller. Let's go into our inventory manager, and let's do a fire rate for this current weapon. I'm going to say public float fire rate, and let's set this to 0.1 or 0.15f. Okay. Then onto our controller, we can just go and do, let's compile everything, and let's do public void handle shooting. Okay, then we want to have a float last shot, and we're going to say if time dot real time since startup minus last shot is greater than your current weapon, or inventory manager dot current weapon dot fire rate, then you're actually shooting. Then last shot will be time dot real time since startup. Okay, then we can go onto our inventory manager and add the particle here as well. Particle system, muzzle particle. Okay. Let's go back to our controller. And let's do inventory manager dot current weapon dot muzzle dot play. Okay, so this will shoot, but yeah, we need to fix this slightly. We need to assign the muzzle flash effect first of all. And we also need to actually handle like this. So we're going to do if you're aiming, and if input dot get mouse button, the left click now. Of course, we're going to change this later. Controller dot handle shooting. It needs some work. But we do have shooting, at least. Okay, and okay, let's try parenting this underneath the weapon then. Maybe it looks better, maybe it doesn't. We'll see. Since we're not, we're basically just using any animations we have right now, so that means we are not going to have a lot of options. And let's see where that is. That's pivot. Let's drop it down here. And I think rotation should be reset. Okay, and rotate that to look forward. That's slightly better. But if you are over there, that should make it even better. Okay. Yeah, okay. Let's keep it like this. Then it's kind of missing something, so I'm going to make a line renderer. Actually, do we need a line renderer? Yeah, we actually need to make this slightly differently. But first, we're going to say that when you're handling shooting, you're also going to be doing a raycast hit if physics dot raycast transform dot or m transform, or let's do this like this, origin transform dot position, or m transform dot position, better yet, origin dot y 1.3 f or something like that, origin m transform dot forward, layer mask. We actually want to just add it on everything, out hit, and let's do 100. Okay, so if now you hit an AI controller, so if AI controller AI equals AI controller, or hit to transfer dot get component in parent AI controller, if AI is not null, then debug.log hit opponent, or just hit, I guess. But for right now, I just want to do a debug draw array from origin m transfer dot forward. Let's do color dot, let's do white, forward by 100. So this will also handle our shooting, our bullets. If we turn on gizmos, and for whatever reason, I think our particles are still off. Yeah, okay. Copy component, paste component values. Yeah, we can't override it. Now it should look slightly better. Yeah. Okay, and now this actually is firing. It's throwing out bullets. With a little bit of better animation, this will look even better, but you know, beggars can be choosers. We can fix that, however. We can change it later. So now we are shooting as well. Okay. And when you are hitting the player, the enemy, we will see that we will also get the debug log hit for that. Awesome. So we can now handle shooting. So for shooting, let's create utilities first of all. And let's create the interfaces. Let's open the tab. Then add the namespace. Okay, and we don't actually need this at all. and we're going to make this as I suitable, or public interface I suitable, better yet, void on hit, who actually hit you, and we kind of want to know, we probably want to know the direction we got hit from, who got us hit, but most of all I would like to have the string hit effects. Okay, so we're going to use that. We can't use it like this, so we're going to say get hit effects. Okay, so for this to work, we now need to have an object pooler. So let's create one object pooler. Let's open it up. Now the namespace. So for the object pooler, this is going to be a scriptable object first of all. So create asset menu. Then we're going to have system.serializable public class pool. Okay, then we need to have our prefab. We need to have our budget. Let's say 5. We need to have a list of created objects, which is not going to be serialized inside our scriptable object, and we want also an index for this. So void get object if created objects dot count is less than the budget. This needs to be returning a game object actually. Then we're going to be creating a game object, instantiate. So from game object dot instantiate prefab as game object, okay, and add it onto the game object. And we're also going to actually do this above and return me the game object. Okay, else index plus plus if index is higher than the created objects dot count -1, index is going to be 0, and return created objects index. Okay, so okay, so yeah, that should work. So we need now a public pool from pools, okay, then we need a void init, and we need a fast method to get options based on their names. So we're going to have a string and a pool for pool dictionary, and let's assign an ID here so it's easier to fix. And we're going to do for each pool in P in pools pool dictionary dot add p dot pool ID, and the value of course will be p. Then public game object get object string ID, and we're going to want to find our pool dictionary dot try and get value ID out pool value. If value not equals null, return value dot get object, else return null. Okay, so where do we access the object pooler? We're actually going to just make a manager or game references, whatever you want to call it. It's not going to be a mono behavior, and it's actually going to be a static class, which is going to have an object or static object puller property and a public object puller property. Object puller, and we're going to have a get set. Actually, we only need a get from this object puller, but if object puller is null, then what we're going to do is object puller equals resources dot load object puller as object puller, okay, and we're also going to call the init method for this the first time, so it's going to populate our dictionary. Okay, so where that's going to happen, we're going to say that on the AI controller we're going to add iSuitable. We're going to implement the interface. Let's go down. So for this I'm just going to hit to add the string, hit effects, and we can just say blood or something. And for that just return me hit effects. Okay, we'll do the rest one layer above. For that we don't need something right now. So on our controller, when you are shooting, instead of AI controller, just find me the iSuitable. iSuitable, or just suitable, I guess. And say that if suitable is not null, for right now, just find me the effects, find me the game object, and we're going to get the game object from game references dot object puller get object suitable dot get hit effects. Okay, then effects to transform dot position is going to be the same position as our hit dot point, and effects dot set active to true, which means once we are getting the object, we're going to say value dot or game object go value dot get object. We're going to disable it here and return that game object, so we can open it and the particles will play basically. Okay, so get object, game references, okay, awesome. So we have all that done. We should probably fix the direction as well, but I guess we can just say okay, let's do fx.transform.rotation to be quaternion.look rotation hit.normal. Let's try that and we'll see. So we need to set up a few things first before this is actually working. And we need to go over here and create a folder that's called resources. Then we're going to create the object puller. We're going to have to name it object puller, just like this. I'm going to make a size. The first one is going to be called blood. Prefab, let's find something, blood spray effect or whatever, and I'm going to set budget to 4. The enemy has the blood hit effects. Okay, hit play. And you can see that we're actually shooting him. Of course, they are set to always animate from what I can see. So they can just, yeah, they don't have to loop, to be honest. So let's find it from the object pooler, blood spray effect. Let's not make it loop. Okay, that's one way to do this. So let's say that if you do not hit suitable, just find a default object and place it there. And instead of suitable get fixed effects, let's just say default. Let's find it. Object pooler, default, and instead of blood spray effect, let's assign something else. Let's say bullet impact. Let's see what is sound effect. Let's just use tone effect. Let's open this up. Okay, it's not looping. Okay, awesome. Okay, and now you get the idea. We're actually shooting everything. We're actually shooting our level. Okay, and we get some feedback at least from where we're shooting. Which is pretty cool. Awesome. So let's see how we are on time. Okay, we have some time, and let's see what else we can do. Well, actually, we don't have much that we can do without animations, to be honest. So yeah, the other thing that we can fix is that this is pretty straightforward. Okay, so this will go no matter how you are actually shooting. It will always go on the same position, which is not that great, to be honest. So here's what we can do. First of all, we can find a random rotation, a random position. Okay, and we can use random dot inside unit circle by, I think, 0.3f. It's probably more than enough. And now we have a random position. We need to turn that random position to be relative to our own transform. So random position equals vector3 dot, or not vector3, m transform dot inverse transform. And yeah, actually just transform point without inverse. Transform direction will give you the direction. Transform point, so it's going to take it as locally and it's going to use it as wall position. So on that origin, if we add that random position, we should now have random bullets, or yeah, more randomized bullets. Let's see. And maybe not. We're actually not hitting anything. And I think our draw ray is happening. Yeah, our draw ray is happening before that. So let's check it now. And yeah, I don't know where that is coming from, but we forgot to do something, I guess. Oh, because it's happening, it gets onto a random transform point. And we're adding that. Yeah, I think. let's say we use the random position instead of our origin. Yeah, so it's basically going from our player. We just need to raise this up slightly. So origin, we can get rid of that, and we can take that. Origin, origin, origin. So definition can be here, this can go away. Origin, origin, origin. Okay, and all we have to do now is raise the origin slightly above ground. 1.3f, probably this will do it. Okay, so now we're actually shooting, we're randomly shooting onto our level, which is what we wanted. Of course, the spread can be based off the weapon. So that means we can go on to our inventory manager and say public float weapon spread. I'm just going to say 0.2, I think 0.3 was too much. And we can do inventory manager dot current weapon dot spread, weapon spread. So the pistol will be more accurate than the rifle. So of course the same thing can happen with the enemies. They can shoot us when they want to based on this. Okay, so let's go on to the AI controller. Actually, you know what? Let's leave that. We'll add the enemy shooting at us on the next part. But it's actually pretty cool the way this turned out. And I think we can raise the budget for this, for the default one, to maybe 20 even. And finally, actually, we're also going to parent them underneath our game object. And I think, yeah, this is definitely wrong. Let's see. Oh, and I think this game object, they actually have, yeah, they have a destroyer. We don't need a destroyer for that. And we definitely don't need the destroyer onto the blood. Although I think this was on looping, so it shouldn't matter. Let's try that. So yeah, on the left side we kind of have an issue. On the right side it works fine. I don't know why that is, but maybe we can just select them. Oh, they actually show, it's just the angle that is not working for us. Oh yeah, because they are above ground slightly. Anyway, that's more of a problem with the particle. So that's it for this part. On the next part, we're going to add the enemy actually shooting at us. So you know what to do. As always, like, subscribe, and if you like to see more stuff, more videos, more series, more of everything of this, then consider supporting my Patreon so we can keep making everything we're making. I'll see you next time.